we will see how to obtain the graph of cosine theta. I'm going to use the definition of these trig functions using x, y, and r whenever those graphs are drawn. So the cosine theta, how did we define cosine theta? We defined cosine theta as x over r. What is x? What is r? Remember, we had a circle whose radius is equal to r centered at the origin O of the OXY plane. If you can't remember that, let me quickly go ahead and draw it. We have those x and y axis, and then we had origin shown as O and the x-axis labeled as capital X and the y-axis labeled as capital Y. And then we simply had a circle. Let's assume that this is that circle whose radius is equal to r. And then we measured an angle theta from the OX axis, and we said if you measure theta clockwise to this direction, it's going to be negative, and if you measure theta counterclockwise to this direction, it's going to be positive. And then we can show the angle theta, and we always go for the first quadrant for simplicity. And this point right here was labeled as point P with coordinates lowercase x, comma lowercase y. The angle right here is angle theta. Now, if I draw a perpendicular line from point P onto the x-axis, I will have a nice right triangle. This angle is going to be 90 degrees. We know that the length right here should be equal to x, and this length right here should be equal to y, and the hypotenuse should be of length r. We have seen this circle of radius r several times in the past. Therefore, this is not anything new. When you have that set up, we can easily write down cosine theta as x over r, because we know that cosine theta is defined as adjacent divided by the hypotenuse. Now we will look at the possible boundaries for cosine theta. It's easier by looking at the coordinates of this point P at these special places, such as on the x-axis, the starting point, on the y-axis, which is the first stop, and back on the x-axis onto the negative side, which is the next stop, and back on the y-axis to the negative direction, which is the third stop, and back on the x-axis right here as the fourth step on a positive journey of theta, which means a counterclockwise rotation of theta. So if your P is going to be at this point right here, what are the coordinates? We know that the x coordinate should be equal to the radius, which is equal to r, and the y coordinate is equal to 0. Let's say that theta is rotating from that x-axis onto this y-axis, and then that new position of P is right here. At that place, your x coordinate should be equal to 0. The y coordinate should be equal to the radius, which is equal to r. Let's say that theta is now starting to move from here up to back on this x-axis onto the negative direction. That means the new position of P is right here. In that case, the x coordinate can be seen as negative r, and the y coordinate is equal to 0. Let's say that P is now moving again until the negative direction of the y-axis. That means the new position of point P is right here. The x coordinate at that place should be equal to 0, and the y coordinate should be equal to negative r. And then if that point P moves back onto the x-axis, it will once again have these same x and y coordinates. Now assume that the point P is in between any of those stop points that we considered. Let's first consider this first quadrant. Point P started right here with x coordinate equals r, and then point P landed at this place with x coordinate equals to 0. What has happened? The x coordinate has decreased from r to 0. Similarly, if you pay attention to this point and this point, the x-coordinate has reduced from 0 to negative r. By paying attention to this place and this place, we can see that the x-coordinate has increased from negative r to 0. And by looking at these two coordinate points, you can see that the x-coordinate has increased from 0 to r. This means we can see that x is always going to be bounded above by positive r and bounded below by negative r. Please note that we defined cosine theta as x over r. Now if I go ahead and divide all of this inequality by r is the radius and r is a positive value always. So dividing an inequality by a positive quantity will not change the inequality. So when I divide everything by r, that inequality then becomes, this is going to be equal to negative r divided by r is equal to negative 1. And in the middle, I have x over r. We know that x over r is equal to cosine theta. So I will write it as cosine theta. And the upper limit, r divided by r, is equal to positive 1. So please note that cosine theta will always be bounded between negative 1 and positive 1. Now we will go ahead and obtain the graph of cosine theta. However, for the simplicity, I'm going to assume that radius is equal to 1. Let r be 1. In that case, we can write down cosine theta. We know that cosine theta was defined as x over r. When r is equal to 1, cosine theta simply becomes equal to x. Now I'm also going to update these endpoints with r equals 1. When I do so, this coordinate point right here becomes 1, 0. This coordinate point right here becomes 0, 1. This coordinate point right here becomes negative 1, 0. This coordinate point right here becomes 0, negative 1. Now I will look at these new x values of these coordinate points because I'm looking at a unit circle. Alright, let's start drawing the graph of cosine theta. As always, we are going to need those axes, the y-axis and the x-axis, but I'm going to label those two axes slightly differently. Right here we have the origin. I'm going to label the x-axis as axis for theta. I'm going to label the y-axis as the axis for cosine theta. As we saw earlier, cosine theta is bounded below and above by negative 1 and positive 1 respectively. Therefore, let me go ahead and show those boundaries as well. Let's assume that negative 1 is somewhere here. Let's assume that positive 1 is somewhere here. We need to show those points as positive 1 and negative 1. Now I simply need to look at the change of x value of the unit circle as theta rotates around that circle. Note that the new radius of our new circle is equal to 1. It is not just r. So I have to pay attention on these highlighted coordinates in green. Please also note that since we pay attention on these special points, 1 point right here, 1 point right here, 1 point right here, 1 point right here, and then again back on this x-axis, we have to pay attention on the values of theta at each of those places. We know when p is right here, theta is equal to 0 degrees in terms of radians, also it's 0 radians. When theta is on the y-axis right here for the first time, theta is equal to pi over 2 radians in terms of degrees, 90 degrees. When that point P is right here, theta is equal to 180 degrees in terms of radians, pi radians. When theta is back on the x-axis onto the negative direction right here, we know that theta is equal to 270 degrees, or in terms of radians, it's 3 pi over 2. when that point P is back on the x-axis right here, it has completed a complete circle, meaning that theta should be equal to 360 degrees, or in radians, 2 pi radians. So those are important values of theta. So let me go ahead and show those points on the theta axis before drawing the graph of cosine theta. We're going to need pi over 2. We're going to need pi. We're going to need 3 pi over 2. And we're going to need 2 pi. Now assume that instead of the point P rotating counterclockwise like this, for all thetas to be positive, let's assume that point P started from the x-axis and rotated clockwise. In that case, I have to show those angles as negative angles. Therefore, let me also show those values onto the left-hand side. I will need a negative pi over 2. I will need a negative pi, a negative 3 pi over 2, and a negative 2 pi as well, if it completes a complete circle to the clockwise direction. All right, now we will pay attention on that x-coordinate of the unit circle as that point P rotates. Initially, we will assume that the point P is on the x-axis right here. When point P is on the x-axis right here, theta is equal to 0, and when theta is equal to 0, the x-coordinate is equal to 1. So let's go ahead and show it as that, as a coordinate point. When theta is equal to 0, since cosine theta is equal to x, we know that as theta is equal to 0, cosine theta is equal to 1. Now we look at the case where theta is equal to pi over 2. Theta is equal to pi over 2 means the point P is right here on the y-axis onto the positive direction. When point P is right there, the x value is equal to 0. Once again, since the x value is cosine theta, I have to show that as theta equals pi over 2, cosine theta is equal to 0. Now we look at the case where theta is equal to pi. Theta is equal to pi means point P is back on the x-axis to the negative direction. In that case, the x-coordinate is equal to negative 1. Once again, since the x-coordinate is cosine theta, we show that as theta equals pi, cosine theta is equal to negative 1. Now I need to see the case where theta is equal to 3 pi over 2. When theta is equal to 3 pi over 2, point P is back on the y-axis to the negative direction. In that case, the x-coordinate, or in other words, cosine theta, is equal to 0. Therefore, as theta equals 3 pi over 2, let me show this point, cosine theta is equal to 0. When theta is equal to 2 pi, which means when that point P is back on the x-axis right here, once again the x-coordinate is going to be equal to 1, which means cosine theta is going to be equal to 1. So as theta equals 2 pi, let me show that cosine theta is equal to 1. Now we can look at the same characteristics as this theta is rotated clockwise. If theta is rotated clockwise, please pay attention that it's going to start from the x-axis and the first ending point will be right here. That will be on the y-axis to the negative direction. We already know as theta equals 0, the x-coordinate is equal to positive 1, and we have already shown that on the graph. At this first stop point, when P is right here, we know that theta is equal to negative pi over 2, and at that point the x-coordinate is equal to 0. So let's go ahead and show that on the graph. Since the x-coordinate is equal to cosine theta, when theta equals negative pi over 2, we have cosine theta is equal to 0. Similarly, when theta is equal to negative pi, which means on the clockwise direction, the point P is right here. In that case, on the unit circle, the x-coordinate is equal to negative 1. Therefore, When theta is equal to negative pi, cosine theta is equal to negative 1. When theta is equal to negative pi, cosine theta is equal to negative 1. Similarly, when theta is equal to negative 3 pi over 2, which means point P is back on the y-axis, but this time on the positive direction, we can see that the x-coordinate is equal to 0, which means cosine theta should be equal to 0. When theta is equal to negative 3 pi over 2, cosine theta is equal to 0. Similarly, when theta is equal to negative 2 pi, which means point P is back on the x-axis right here, the x-coordinate is equal to 1. Therefore, at theta equals negative 2 pi, cosine theta should be equal to 1. All of these points are points on the cosine theta graph. So now we can quite easily go ahead and connect these points. These points are not going to be connected using straight lines. Just like explained during our video for the graph of sine theta, we have to connect these points using curves. Why? Because towards these extreme points, such as positive 1 and negative 1, the rate of change of x also very clearly reduces. Therefore, we will go ahead and draw the cosine curve using not straight lines, but curves like this. Alright, that's it about the cosine graph. Now we will look at the period of this graph. The period is defined as the shortest distance on the graph between 2 points where the tangents are parallel. Now consider the point right here and the point right here. If I draw tangents at these 2 points, one tangent will be like this, the other tangent will be like this. They are of course not parallel. However, if I consider a point like this and a point like this, if I draw tangents at those 2 places, they are going to be very clearly parallel. One tangent will be like that, the other tangent will be like this. Of course, this is just a sketch of this graph, therefore they are not very perfect, but you can see that they are going to be parallel if I pick those 2 points. Therefore, we can identify this gap right here as one period. To find that gap, I need to calculate 3 pi over 2 minus negative pi over 2. That simplifies to become equal to 2 pi. Therefore, the period is equal to 2 pi. Similarly, we can identify the amplitude. The amplitude is defined as the distance from the center line to the peak. We know that the center line is at 0 and the peak is at 1. Therefore, the amplitude should be equal to 1. These 2 pieces are exactly the same as the sine theta curve. Alright, so that's it about the graph of cosine theta. Thank you so much.